Welcome to our presentation. It is regarding infusing machine learning in cognitive psychology and cognitive bias analysis, enhancement of the computer science and psychology curriculum. It is an NSF project, and my team members are Dr. Sheila Peters. She's associate professor in psychology. She's the PI. Myself, Dr. Sajid Hussain. I'm an associate professor in computer science at Fisk University, and Dr. Michael Watson. He's a professor of physics at Lipscomb. So this is our abstract. So the idea of this, our proposal is uh, to engage our students in psychology and social sciences, for engage them in machine learning and computational thinking in these applications. To train our students for this quantitative and computing skills. So we introduce a new course, and we have the student some research experience, and we develop course modules. So just as a comparison, in old days, in Middle Ages, only selected people used to read and write, only priests and scribes. But then afterwards, it became common knowledge that everyone start reading and writing. Something similar is happening right now for computational thinking and these quantitative skills, that now everyone should be trained. That's why we are focusing on social sciences as well. And there are, of course, plenty of job opportunities. Uh, According to our this NCVIT survey, there were 4.7 million computing related jobs by 2030, and only 20% will be filled by these jobs, could be filled by the US computing bachelor's degree. So we need more majors. So here is our experiment regarding machine learning courses for social sciences. We launched in fall 20, we got 24 students. In 21, we had 32 students. Now we also added another variation of course, data science for social justice. We have 20 students already enrolled so far. So this is the overall view of the machine learning course. This course introduces students for machine learning for social sciences and for all majors. Topics include but not limited to machine learning algorithms, models, core machine learning concepts, classify examples with classifiers, and regression. So it is a decent machine learning course where where we engage students without going into deeper into linear algebra or calculus. Still high level using scikit-learn of Python in Jupyter Notebook, so students can plan it. Students' learning outcomes are students are able to apply machine learning techniques for problem solving. They can investigate machine learning for cultural bias in the software tools. They can design and create software applications based on machine learning, and they can apply latest best industry practices in developing these machine learning applications. Although it was not intended, but our enrollment also significantly increased uh, based on this interest in computing. Many interdisciplinary majors, they showed interest in doing joint majors and others. And you can see in computer science in enrollment each semester from fall 2019, it was around 30s and 80s, 90, now 153, and also data science. So our combined enrollment for CS and data science together is significantly increased in these years. And if you see the overall ratio compared to other majors, so we can see that computer science and mathematics is on rise. Is the impact people are showing interest. Life sciences over here, and the social sciences pretty straight, but our percentage of this one is rising. And so we were low actually 6%, and now with spring 22 we reached 17%, so it's a significant increase. If you see the national average, this is from NSF side. So national average is actually going down. And despite those amazing job opportunities for these, our maths responsibility decreased from 11.2% to 8.9% in computing and math majors, and math from 5.3 to 4.8. So as you can see over here in the computer science major, in the purple, it declined recently. So regarding our computational thinking, what are the focus for student learning? Students are able to decompose a bigger problem into smaller problems, manageable problems. They can identify the patterns in the data and in the similarities. They can also do the abstraction, identify the most relevant information and ignore the irrelevant. And also they develop the algorithm, develop step-by-step process. As you can see, it happens in all different areas. Even solving a crime, you break down the problem into smaller problems. Even in identifying the patterns, you can see our algorithms, like this person was identified as a low risk, but he was actual criminal, and she was applied as a high risk, which was wrong, just like a petty theft. So there's a problem in our algorithms. We need to improve them when we're identifying the patterns. We also patterns we can also use even in the music when we are composing. This is a Python code to compose the music. We use the Georgia Tech tool, ear sketch, to compose the music, and there's a pattern over here. You can compose different music. Abstraction is that students are able to identify the most relevant information. Is a toy example. So this is just right picture of the heart. This is too much detail. This is oversimplified. So just get the right details. This is also important skill. For example, we have different layers. For example, we have traffic information or biking or trails from this Google map or transit or train. You don't want to bring everything on the same map, otherwise there will be too much noise. So filter the information. Also, we apply that for finding these one abstraction on this other in the our computer vision examples, edge detection, what to focus on. The fourth one is algorithm. Have a step-by-step procedure to solve the problem. It could be on making a coffee or tying your shoe laces or solving the Rubik's cube or folding. So algorithms are everywhere. We also use NSF-sponsored validated rubric to evaluate the student assignments and course projects. Here are some sample assignments. For example, Google Vision API, we want to check it if how accurate it is to identify the African American or other. So it is a picture. So the baby was not identified. This green means the face was detected. So the mom's face was detected, but not the child one. And we also upload the other picture as well. Here's another example of doing linguistic analysis that we use. For example, for Bible, we analyze where Moses appeared in Bible, this green color, where David appeared in blue color, where Jesus appeared. And those, even without reading a Bible, you know that the story of David is in the middle mentioned more often. Story of Moses in the beginning, and Jesus came at the later. And we can also identify it about Lord, King, and God. And you can see over here too that the mention of God, this purple, was very high near the end, and the mention to King goes down. So more talking about God near the end of the Bible and less talking about King near the end. In the middle, King is quite high and God is a bit low. And then very beginning, King is low and God and Lord are high. So these are those who are deeper into Bible, they can provide more details. But even by this quantitative analysis, we can review the story or overall the theme, what is emphasis. We also use some even Excel based our examples. Here is a more deeper code of having same. This is a music. You can have functions defined, and then you can run it. We also ask students to make their e-portfolio to share this the outcome with the other audience on that site. So these students make their website and share their information over there. So thank you so much for your time. I really appreciate it. Thank you. Take care. Bye.